Okay, so now we're going to get to talk about adding and subtracting radicals. We talked about simplifying before, but now we're going to talk about adding and subtracting. So the idea for adding and subtracting is actually very similar to something that you probably already know. If I were to give you an example like 5x plus 3x, everybody probably already says that's 8x. Kind of second nature. What happened is those were what we called like terms. Okay, and it's actually going to be very similar for the radicals. What we're going to talk about with the radicals is instead of calling it like terms, we're going to just call it like radicals. So that is what we are searching for when you're adding and subtracting these radicals. Now in this example, the square root of 18x minus the square root of 72x, those are not like radicals. One has an 18, one has a 72, so we have to be careful with that. We're going to have to break it up, simplify each one separately before we can start combining anything. So 18, I'm going to look at the 18 first. That can definitely be written as 9 times 2. Now I chose that again because I know the square root of 9. So square root of 9 is 3, so that's going to come on the outside. The 2 and the x I did not know the square root of, so they stay on the inside. Minus. Then we're going to do the same thing with the other radical, square root of 72x. Now 72, I need to be able to see if I could break that up. Now, some of you may have thought of 9 times 8. That's fair, because you know the square root of 9. I get that. However, you have to be careful because couldn't you have written that just the same as 36 times 2? You pick the highest number that you know the root of. In this case, 36 is higher than 9, and I know the root of that. So the square root of 36 is 6. And then the 2 and the x I don't know the square root of, so they are going to stay inside my radical. Okay, and that's what we're going to do. Simplify each one separately, then look at it as a big picture. There was a minus in between, so I just dropped it down. Now, if you look at this as the big picture, are they like radicals? Okay, do they both have the square root of 2x? Yeah. They both have an index of 2. They both have a 2x as the radicand. They are definitely like radicals. So once you find out if they are like radicals, you can combine them. So 3 minus 6 gives you negative 3. And then the square root of 2x stays the square root of 2x. And that's how we're going to add and subtract these radicals. Let's go ahead and do another problem. Okay, let's go ahead and do one more with numbers that small, and then we'll start throwing in more than one variable. So let me write up another one. What if I were to give you 2 times the square root of 5 minus 3 times the square root of 20 plus 4 times the square root of 45? Let's talk about that. Now, each one of those has their own radical. You're right, none of those are like radicals, so we need to go ahead and break these up. 5 can't be broken up at all, so I'm going to have to just leave that the same. 20 can be broken up. I can write that as 4 times 5. Do I know the square root of 4? Yes. So you have to be careful with how you write this. I'm going to just copy down that 2 root 5 so I don't forget it. Now the minus 3 on the outside is just a minus 3 on the outside. There's nothing you can do about that. The square root of 4 is 2. But you have to be careful. It's a 3 times 2, not a 32. So when you think about it, this is a multiplication. So the 3 drops down. When you take the square root of 4 to be 2, it will be 3 times 2. And then again, the square root of 5 I don't know, so it stays inside. Plus, the 4 on the outside stays the same. And then we got to look at that 45. How can I break up 45? Well, that could be written as 9 times 5. And do you know the square root of 9? Yeah, I do. It's 3. Square root of 5 you don't know, so it's going to stay there. I'll go ahead and rewrite this. I have the 2 square root of 5. Now this becomes minus 6 square root of 5 plus 12 square root of 5. Now you can notice whether or not they're like radicals. In this case, all 3 of those are like radicals. And again, be careful. Only combine the ones that are like radicals. In this case, they all are. So 2 minus 6, which is negative 4, plus 12, which would be 8. So I have 8 square root of 5. And that's how that simplifies. Okay. All right, let's go ahead and do one more. Same idea. Still going to add and subtract these like radicals. I'm sorry, yeah, these are radical expressions, but we have to wait until they are like radicals. So the next one I'm going to do is a little bit more complicated. I'm going to make this x squared y times the 4th root of 625 x cubed y plus, and then I'm going to do the 4th root of 81 x to the 11th, y to the 5th. Significantly harder. Bigger numbers, but we can do this. Alright. First thing I'm going to do is look at those numbers, 625 and 81. And see if I know the square roots of those. Sorry, not the square roots, the fourth roots of those, because we're dealing with the index of 4. So let me write down all the fourth roots that I know. The fourth root of 1 is 1. Right? What's the fourth root of 16? It's 2, because 2 to the power 4 is 16. What's the fourth root of 81? It's 3. Again, because 3 to the power of 4 is 81. And then maybe some more. What's fourth root of 256? That's 4. Again, because 4 to the power of 4 is 256. Fourth root of 625 would be 5, because 5 to the power of 4 is 625, and so on. Now I'm going to stop here because I notice I have a 625 and an 81, which I have. That'll make my life easier. So let's go ahead and deal with those. I'll erase those other ones. That'll work out nicely. So we will have there we go. So the x squared y is going to stay there. Okay. 625, the fourth root of 625 is 5. The fourth root of the x cubed and the y, neither of those I knew. Okay, so those are going to stay underneath the root. The other thing that we're going to talk about for this other radical is that x to the 11th can be broken up. I can think about, now 81, I'll know the fourth root. I can break up x to the 11th to be x to the 8th and x cubed. X to the 8th, I know the fourth root of because 8 divided by 4 goes evenly. And the same thing with the y, I can make that y to the 4th and y. Again, I know the fourth root of y to the 4th because 4 divided by 4 works evenly. So when we simplify this out, I'm going to give myself some more room here on the bottom. Alright, so I'm just going to rewrite this one, 5x squared y, fourth root of x cubed y, plus. Now the fourth root of 81 gave me 3. The fourth root of x to the 8th gave me x squared. The fourth root of y to the 4th gave me y. And then the things you don't know were the x cubed and the y, so they stay underneath the radical. And then now you can notice that they are in fact like radicals, and they also are like terms. They both have the x squared y, and then they both have the fourth root of x cubed y. So those can be combined. 5 plus 3 gives me 8. The x squared y stays the same, and the fourth root of x cubed y stays the same. Ta-da!